Okay, everybody, so I was getting a lot of the oops screens like y'all were too, but I'm going to come, instead of clicking on the lab link, I'm going to come back up here to the IT Pro TV authentication link. This was in the preview week preliminary coursework. And if I click on it here, then it will actually take me to this section and I can go into my virtual labs. These are for CCNA. Then I click on the course and it gives me all the modules. Okay, here we're going to be looking at the ones for week 4, switching fundamentals, part 1 and part 2, and then configuring VLANs, part 1 is the graded section, but we will be working through all 3 labs here. Okay, so here we're going to be looking at examining the functionality of a MAC address table and the address aging, frame switching and frame flooding methods, configuring and understanding CDP and LLDP, and then configuring static, PAGP, LACP, and Layer 3 Ethernet channels. Okay, so we have the following configuration: NY Core 1, NY Core 2, and this is NY Access. So this makes a triangle configuration here. For that we have NY Edge 1, NY Edge 2, NY WAN 1, and a PC down here. Depending on the exercise, we may or may not be using each of those pieces of equipment. So first we're going to look at the MAC address table, also known as the Content Addressable Memory Table. It's a data structure that's created and maintained by a switch to keep track of which in-device MAC addresses are associated with which switch port. So if you walk in and you connect into a network, you're assigned an IP address, and that IP address is tied in with your MAC address in this MAC address table. In this exercise, we're going to examine how the MAC table functions in order to understand its purpose more fully. Okay, so in task 1, we'll take a look at the lab diagram, which we already did. We're using and examine which devices are directly connected to NY Core 1 switch and to which ports they're connected. Examine the following list and confirm these devices are connected to the ports in the list. Alright, so NY Edge 1, Fast Ethernet 00, okay, so it's connected there to FA101. And NY-WAN2 should be off FA02. See if I can get this a little smoother. Sorry, got to go back and forth. NY-WAN1 is off FA102. And I'll let you configure the rest of those or verify those yourself instead of me going back and forth. Oh. Determine the states of these ports on NY Core 1 switch by using the following commands. So we'll go to NY Core 1. Make sure that's what you see up here. enable. As soon as I can spell, enable, and show interface status. Okay, and apparently I can't type today. My apologies. Show interface status, and it should show us each of the ports, whether they're connected, and what their duplex mode is, and the speed that they're set at. And you can press the space bar or enter there, and then you'll see the other connections they're referring to here, 22, 23, and 24. 23 is not connected. All right. You'll notice that of the above listed ports, they're all connected except for the FA102. I think that's connected to WAN 1. It is connected. Okay. To display and examine the MAC address table on N1, NY Core 1, we do show MAC address dash table. I said dash and still forgot to type it in there. Okay. And it shows the table we have listed. Various MAC address, and then the port that they're available off of. Enter moves one line at a time, whereas the space bar will scroll to the next page. MAC addresses with the destination as CPU in the port column that has been created and is statically assigned by the system to allow for functioning of various processes and protocols such as CDP, VTP, DTP, to name a few. Use your favorite search engine to research these protocols. At the bottom of the MAC address table, we'll see several entries with the type designated as dynamic. Each of these addresses corresponds to a physical port on the switch, which is indicated in the port column. Note the following. The dynamic designation indicates that this MAC address has been learned dynamically by the switch based on the source MAC address of incoming frames on these ports. So it got data from those ports, and it knew the MAC address, or it learned the MAC address. Whenever the switch receives a frame that has a destination MAC address of, let's say, 7426 AC 67 OC 70, it will not send the frame out to all ports like a hub, but it will look that address up in the table and determine the corresponding port that it's associated with. There are 3 MAC addresses that correspond to FA1 022, This is because there are multiple devices connected to that port, not directly but indirectly via NY Access 1. Specifically, these devices are the PC server, NY Access switch, and NY Core 2. This step will determine where one of the three MAC addresses that corresponds to port FA1022 comes from. Connect to the PLAB server. Right-click on Start Windows Charm and select the command prompt Admin. Okay, so I'll scroll down and get to the PC, and I have to turn it on and wait for it to boot up. So once it boots up, we make sure we launch it. It should have come up. There it goes. And I can see the name up here. And it's just come down to the Windows icon. Right click. And we should see command. Oh, I did not get the admin, so I'm going to close mine and do that again. Although it says administrator, I want to make sure I did that right. And you want to do an IP config space /all. Okay, now that shows us all the ports off of the PC that are being used. The output shows several network interface devices. We want to look for, and I went the wrong way to look for it. Okay, so you can see here the host name and the Ethernet adapter lab_NIC. And we should see the IP address. Dang it. (192.168.16.10). And then we look at the physical address, 1005056. Mine's a little different than theirs. But that address should correspond to one of the addresses in my table on NY Core 1. Okay, it wasn't matching, so I went back and did my show again, and now it's showing up. There's my address here that was coming in from the PC. Okay, and I'm a little bit too far. Another of these three addresses should come from NY Access 1 switch, which is directly connected to the interface in question. NY Access 1. So make sure I'm on NY Access 1 here. And enable. Show interface FA024. Okay, and in here we should see the MAC address. I guess again their address is different than ours, so we have to use the one that we get. And I can go back and compare that F4AC to my table, and there's the other address. Okay, the next we'll activate NY-WAN1 router interface that connects to NY Core 1 switch. Look at the lab diagram, determine which interface on NY-WAN1 must be brought up in order to successfully connect to NY Core 1. The interface should be G00. Alright, so I'm going to run back up here to the diagram real quick and look, and NY-WAN1 G00 is connected to NY Core FA102. Nope, this one, there we go. Okay. Alright, so to do that, we would use show IP interface brief. This gives us a list of the interfaces, and we can see here FA02 is up. This says they're all down. I'm not sure why. All of mine weren't down, but oh, that's why I'm on the wrong one. We should be on NY-WAN1. So I'm back on NY-WAN1 and show IP interface brief. And here we'll see that they're all down. We're going to activate G00. So we have to go into configuration mode and then go to that interface and do a no shut command. Okay, then we'll come back out. And we should be back here. Notice the system log message that shows us, well, it should have showed me that it hadn't come back up yet. Go back to NY Core 1. And NY Core 1, we want to show the MAC address dash table. Okay, there should be a new entry for us that corresponds to FA02 and is connected to NY WAN 1. Okay. Notice that even though you didn't configure an IP address on NY WAN 1, the MAC address was still learned and the table was populated. This is a very clear example of how network communications are separated into distinct layers. The data layer is functioning fully between NY WAN 1 router and NY Core switch, and all layer 2 functionality is in operation. However, layer 3, or the network layer functionality, is not, since no IP address has been configured. All right, so we're going to go back to NY WAN 1. And NY WAN 1, we're going to show interface G00. Notice on the third line the address there's mine. Looking back at the MAC address table of NY Core 1, 5057, FA02. Up to this point, we've examined dynamically learned MAC addresses. It's also possible to configure a static MAC address entry in a MAC table. Static MAC address entries in a MAC table will always take precedence over dynamically learned MAC addresses. To find out more about why you would configure a static MAC address table entry, use your favorite search engine to research the topic further. Connect to NY Core 1 switch, and we're going to configure a static MAC address table entry. So make sure I'm on NY Core 1. I have to go into configuration mode. Okay, I skipped something there. I gotta go find my MAC address. Connect to NY Core 1 switch and configure a static MAC address table entry for the MAC address of G00. Interface on NY WAN 1 router. This is the MAC address you examined in the previous step. So this one. Configure this address to correspond to FA102 interface on NY Core 1. The MAC address used here is, use the MAC address of your device for your command. Okay, so on NY Core 1, we need to be in configuration mode, and we'll type MAC address dash table. Come on, fingers. Static And I think this will work. If not, I gotta type it out. No, it's not gonna let me, so I can type it out here. 5057 dot A8D3 dot 3C80 VLAN 1 interface FA102. Okay, then I want to exit. And now I'm NY Core 1. I want to show my MAC address table again. It's not letting me use my up arrow. I'm not sure why. Okay. The dynamic entry of the MAC address table. The functionality is the same, however, now NYWAN1 it can now only be connected to FA02 interface of NY Core 1 switch. And you can see it was a static assignment. Okay, now we're on to task 2, adjusting the aging timer. Dynamically learned MAC addresses remain in the MAC address table for a specific period of time. If there's no activity from the specific MAC address after the specified period of time, the address is removed from the switch. It's possible to adjust this aging time according to your network needs. In this task, you will examine MAC address aging. You will adjust this aging timer and observe the results of your changes. MAC address aging occurs only for dynamically learned MAC addresses. Static entries never age out. Okay, step 1. By default, the MAC address aging timer is set to 300 seconds or 5 minutes. Change this default to 10 seconds in order to observe the MAC address learning and aging out process. So instead of having to wait for 5 minutes to get it to timeout, we're going to set it to 10 seconds so it ages out faster. Not typical, but just something we're doing here so we can observe the aging out. Right, so I want to be in configuration mode. My computer is acting really funny. Okay. And MAC address dash table aging dash time 10. and exit. Then I want to show the MAC address table again. And you see that some of those dynamic addresses timed out. Static one's still there. Okay, so they're showing us a couple of examples there. STP, CDP, and VTP are routing protocols that help communication between network devices. And now we're on to exercise 2. Frame switching refers to a method by which a frame is switched or transferred from the ingress interface, or the incoming, to the egress interface, or the outgoing. There are 2 main methods by which this is accomplished: store and forward, and cut through. All frames has a certain size in bytes. The maximum size is usually 1500 bytes. Although this can be adjusted, it takes a finite amount of time for a frame to enter a switch port. So in other words, it takes it a certain amount of time for all those bytes to be read into the port. Depending on the method of switching, this amount of time can add latency or delay to network communications. Latency is not good in network communications. Store and forward does exactly what its name says. It receives a frame, stores it entirely on the switch buffer before it begins sending it out to the outgoing port. It allows the switch to read and calculate the frame check sequence, which is in the trailer of the frame, to verify that there's no errors in the transmission before it sends it out the outgoing port. Both latency and reliability are increased, so it takes longer, but it's more reliable. Cut-through switching begins sending a frame out the outgoing port before it's been received in its entirety. Switching begins once the destination MAC address has been read from the header of the frame and the outgoing port has been determined. Here, latency is decreased, but reliability is not. And the default method for the switches used in the lab is store and forward. In fact, it's the only method of switching that is supported by these switches. Cisco Nexus switches support cut-through switching by default and can be configured for either switching method. Frame flooding occurs when a frame enters a switch that doesn't have the destination MAC address within the MAC table. In this case, the switch does not know where to send the frame, so it sends it to all the ports except for the one it came in on. This is frame flooding. If the device with the destination MAC address in question is connected to one of the switch's port, it answers, "Hey, that's me," and its MAC address will be added to the MAC table. In this exercise, we'll learn about frame switching and frame flooding. Okay, we're going to examine the buffers that are used to store frames as they're switched from ingress to egress ports, or incoming to outgoing. Frame switching refers to the concepts where packets are transferred from the incoming port to the outgoing port. Connect to NY Core 1, which we should still be there. And we're going to do a show interface FA1022. Okay. The output of interest is indicated in bold. I didn't see anything, but oh, okay. Our input queue and FIFO, first in, first out. Buffer failures. All right. The input queue indicates the number of frames in the input queue and its maximum size. Currently, the queue is empty. However, when store and forward is functioning, the incoming frames are stored in their entirety in its queue. Total output drops. This is the number of drops that have been measured due to the queue being full. Queuing strategy is the method by which frames are queued. First in, first out. FIFO. The output queue, the size of the output queue, and the number of frames currently in it. As is quite apparent, the stored and forward method will require more memory usage than cut-through. It's possible to tweak the sizes of the buffers as needed. Okay, go back to NY Core 1, and this time we want to show MAC address dash table, MAC address dash table, dynamic. Oh, I still ain't getting my spelling right. Dynamic. Okay, imagine the PC device chooses to send a frame to a device within the MAC address table. And they're telling us to look at this one on port 1, I think it is. No, hang on. Well, it's not either one of those. Okay. This particular instance, 4 MAC address entries exist, and there are 5,995 spaces available. And so we'll do show MAC address table count. So we have 5, 1, and 3, and 6002 available is what I'm showing. MAC address flooding is a security risk because this functionality can be used to cause the network to malfunction. Imagine that the user of the PC server is a hacker. He can initiate what's called a MAC flooding attack. Essentially, the server would send a multitude of frames, each with a different source MAC address. The switch would then learn all the fake MAC addresses and associate them with the port on which they're coming in. You may wonder how a computer could send frames with many different source MAC address since the MAC address is burned into the NIC and cannot be changed. It is true that a MAC assigned to a NIC cannot be changed. However, when sending frames, the MAC address is read into RAM and then placed in the source MAC address table or field of the header frame. Once the MAC address resides in RAM with the appropriate software, it can be changed before it's placed in the header frame. The result would be a very large MAC address table similar to the following. Notice the total MAC addresses for this criteria is at its maximum, 5,999. In essence, the MAC flooding attack has reduced the switch functionality to that of a hub. There are several ways you can protect your switch from MAC flooding attack. Most of these are found within the framework of port security, which you will learn to implement in another lab of this series. Choose your favorite search engine to research the topic further. Now we're on to exercise 3, configuring and understanding CDP, Cisco Discovery Protocol, and LLDP, Link Layer Discovery Protocol. CDP allows network management applications to automatically discover and learn about other devices on the network, other Cisco devices. LLDP is a standard neighbor discovery protocol for network devices to advertise information about themselves to other devices on the network. This protocol runs over layer 2 as well and allows two systems running different network layer protocols to learn about each other. Okay, we'll be using NY Edge 1 and NY Core 1. And in this task, we're going to configure CDP and understand how it functions. So we want to be on NY Core 1 and do a show CDP neighbors. The above output shows there are 4 devices connected. 1, 2, 3, 4. We can see the device ID, local interface, hold time, capability, platform, port ID. Okay, now we want to do a show CDP entry for NY Edge 1. Notice how detailed the information about NY Edge 1 router is. It includes the IP address, the iOS version, VTP information, and even power management. CDP periodically sends CDP packets to update information between devices. It's possible to adjust the frequency with which these packets are sent. Examine the number of CDP advertisements that have been sent by NY Core 1 device to gauge the amount of traffic that CDP adds to your network. So now we want to do a show CDP traffic. You determine there are too many CDP advertisements occurring, and this is disrupting network communications. You can adjust the frequency with which these advertisements are sent. When adjusting the frequency, there are 2 values that must be defined. The timer, which is the frequency of the advertisements, and the hold time, which defines the amount of time a receiving device should hold the information before discarding it. The default timer value is 60 seconds and the default hold time is 180 seconds. It's recommended that the hold time always be 3 times the timer. For the purpose of this lab, we're going to configure the timer to be 70 and the hold time to be 210. All right, so on NY Core 1, configure terminal, and we'll set CDP timer to 70. Then I want to set CDP hold time to 210 and exit. Okay, now we're going to do the show CDP neighbors again. If we repeatedly issue command, we'll see that the hold time does reset to values up to 210 seconds, thus confirming the change in the configuration. Mine keep coming up exactly the same. I guess my times are coming up different. Okay, now they want us to do a show CDP. This also tells us the version of the CDP that's being used. In this instance, it's version 2. And now they want us to do a no CDP run. Although CDP is very useful, it can lead to network vulnerabilities and security issues. The easiest and most effective way of mitigating those vulnerabilities is to shut CDP down completely. And now we're going to look at LLDP. Okay, so first of all, we're going to connect to NY Core 1, which we're already there. And go to configuration mode and do an LLDP run. Then we'll come over to NY Edge 1. Come on, NY Edge 1. Eh. Messing with me. And so now I got NY Edge 1 up. I'm gonna configure terminal LLDP run and exit. Alright, we're gonna connect to NY Edge 1, which we are, and do show LLDP. It's active. We want to show LLDP neighbors. And we should see NY Core 1. Notice the similarities here between LLDP and CDP, the advertisement and hold time. Here the ratio between the two is 4 to 1 as opposed to 3 to 1 for CDP. to change the advertisement and hold time timers to 48 and 180 or 45 and 180. We'll configure terminal and set the LLDP timer to 45 and LLDP hold time to 180. And then we're going to exit and show LLDP again. We have 45 and 180. And now we're going to look at how to disable LLDP. So on edge 1, we'll be in configuration mode. And issue no LLDP run. Exit and then show LLDP. And it shows you it's disabled. Now our last exercise here is configuring static Ethernet channel, port aggregation protocol, and link aggregation control protocol, and layer 3 Ethernet channel. So we'll jump in here and get started, and we're on NY Core 2. Okay, so the purpose of the Ether channel is to bundle physical switch interfaces together to increase network performance. In this case, we'll learn how to configure a static Ether channel. Ether channel and port channel can be used interchangeably to refer to the bundle of aggregated links. Both port channel or PO is the keyword used when configuring the interfaces. All right. So on NY Core 2, we'll assign a channel with an ID of 1 to each of the Fast Ethernet 23 and 24 interfaces. Make sure to configure mode of on to configure the Ether channel statically. Okay, so we'll start with configure terminal. And we want the int range FA1 023 to 24 channel dash group 1 mode on. Okay, and then we'll do an exit, and we get back to configuration mode, and this time we'll set the interface range. Okay. I swear that's what I just did. Oh, I was on NY Core 1. Now I'm going to switch over to NY Core 1 and do the same thing. Enable from here to go to conft. Then we want int range FA 1023 to 24. Channel dash group 1 mode on, and exit twice. And get similar syslog messages here. About the state of the port channel and VLAN 1. To confirm the channel is operational, we're going to go to NY Core 1 and show Ether channel summary. And it shows me the ports. Alright, now they want us to do is show interface port dash channel 1 Ether channel. We've successfully configured a static Ether channel. Now we want to configure port aggregation protocol. So on NY Core 1, configure terminal, FA 1023, and channel dash group 1 mode question mark. How'd I miss the question mark? Oh, I didn't. Okay. So active, enable LCP unconditionally. Auto enables PHEP only if PHEP device is detected. Desirable, enable it unconditionally. On, Ether channel only is on. Passive, LACP only if LACP device is detected. So we're just going to hit enter. Not sure why, because that doesn't complete the command. Exit, exit. Oh, alright, because it told us to do the question mark. I'm just double checking here that it did not. Channel dash group 1 mode. Okay. Okay, so we're gonna configure the channel group 1 on Fast Ethernet 1023 and 1024 using the auto keyword. Alright, so I'm on NY Core 1, comp T, and int range F1023 to 24, and channel dash group 1 mode auto. Actually, they exit twice there. And you can see the port channel as well as the interfaces in the group go down and then back up again. At this point, the ether channel is configured to be auto PAGP on NY Core 1 and on NY Core 2 end. The ether channel is not currently functioning and additional syslog messages show up on both ends. Okay, now we're going to come over to NY Core 2 and configure the channel group 1. So I'll go to NY Core 2 and I'm already in the interface range and I just need to set channel group 1 mode to desirable. And on NY Core 2 we'll do show ether channel summary. If I can only spell today. Notice the PAGP protocol is used. And now back on NY Core 2. And configure the terminal and set up the interface range FA02 to 23, 23 to 24. Using the up arrow key to keep from having to retype as much. Now I can set the mode to auto. Okay, notice that the physical interface and the port channel interface go down. A few seconds later, the physical interface comes up, but the port channel remains down. A few seconds later, the physical interface comes up, but the port channel remains down. This is because the auto keyword negotiates an ether channel link only if there is a PAGP enabled device on the other end in desirable mode. Okay, to verify the state of our port channel, we'll show ether channel summary. Under the port channel column, you'll see the flag SD. According to the legend, S indicates layer 2 and D indicates down. So in order for an ether channel to function with PAGP, it's necessary to have at least one of the two ends configured as mode desirable. Next, we'll look at link aggregation with control protocol. Link aggregation control protocol is an IEEE protocol that works much the same way as PAGP. With this protocol, Cisco devises and negotiate link aggregation with non-Cisco equipment, and this task will configure NY Core 1 to use LACP.